Thank you then. Well, good afternoon. My name is Emma Dench. I'm a professor of history and the classics, and it's my very great pleasure to introduce Professor Michael McCormick. I think it's extremely important that I give Michael McCormick a shout out, because in all sorts of ways it's his own party and it's very difficult to get a shout out, so I felt very honored that I was able to do that. Michael McCormick is the Francis Gallet Professor of Medieval History here at Harvard, and really has done so much to bring scientific methods and modes of inquiry to bear on historical questions, and I'm so glad to get this opportunity to celebrate that, as well as to hear Mike's paper. I'm very much looking forward to his paper, which is entitled Ancient and Medieval Climate Change and the Future of Humanity. I'm personally very much looking forward to hearing the paper because of what he promises as a consideration of the possible dialogue between, putting it very crudely, scientific and historical materials and methods in the crucial issue of climate change. I know that we as historians rhetorically often either speak to or speak about contemporary concerns all the time, but frankly there's nothing more urgent than climate change that Mike will share with us this afternoon. Please join with me in welcoming Professor McCormick.
Thank you, Emma. And as Emma has suggested, historians and archaeologists usually concentrate on the past of humanity rather than its future. This we know. This was my first reaction when I was invited a couple of months ago to participate in a roundtable in Munich called The Climates of History and the Future of Humanity at the first ever meeting of the International Society for the History of the Climate. Now, as Emma has intimated, professional historians are indoctrinated from graduate school as practically an article of faith that history as a discipline, that is historical research, the study of change in the human past, cannot be used to predict the future. And that is not wrong. That is not wrong. For the extraordinary complexity of history, history is an object of study, not as a discipline. The process of history emerges from the totality of all phenomena, material and mental, affecting all individuals and all groups. And these phenomena operate in non-linear ways, more congenial to physicists' theories of chaos or the behavior of modern markets. Witness the inability of modern economics to predict the financial meltdown of 2008, than they are to Aristotelian logic. And yet, many historians have observed that if historical study does not allow us to predict the future, it surely helps us to understand the present and the potential scope of future developments. In that broad sense, certainly, historical research has something to contribute to the question of modern climate change, since it is now for the first time, becoming possible and indeed necessary for historians to explore climate change in the historical past. SOHP's own Peter Hybers has noted recently in the journal Nature that recent climate extremes are by their very nature rare anomalies, and therefore require investigation on timescales of centuries and millennia, timescales that far outstripped recent climate's instrumental records. In other words, the past is suddenly emerging as dramatically relevant to understanding not only the present, but also in some true sense, the future of humanity. I would go a step further and urge us to recognize in the discipline of environmental and climate history something more. It is a leading edge in the broader transdisciplinary convergence that we are inducing here in this room on this occasion. The transdisciplinary convergence that is bringing the power of the natural sciences to illuminate the human past, and just maybe the power of the humanistic disciplines of history and archaeology to inform and to serve the natural sciences. Climate history seems a perfect example of what our colleague Ed Wilson calls consilience, the jumping together of evidence from completely independent disciplines that converge only because they are united in the reality under investigation. Climate history incarnates the long dreamed of reunification of the sciences and the humanities, especially insofar as it uses the power of modern paleoclimate science to illuminate the human past and perhaps point toward the future. Now, it's important to understand that notwithstanding a few distinguished but isolated forebears, historians' concern with climate change is new. A few pioneers began exploring the theme in the 1970s, and indeed as far back as 1900. But the broad awakening was slow in coming, not least because a robust evidentiary base for knowing past climates was lacking. Just a few weeks ago, I discussed with my students a landmark monograph in Byzantine economic history published in 1985. It was rightly hailed then for its innovative approaches, some of which were plainly inspired by the French Annales school of history, particularly the detailed description of the environmental characteristics of the Balkan and Asia Minor provinces of medieval Byzantium that detailed rainfall and temperature gradients, which conditioned, according to this historian, the economic productivity of a great agrarian empire. This fine historian described them all based on modern meteorological records. It occurred to no one until very recently that precipitation and temperatures might have changed in these regions since that surviving Eastern Christian rump of the Roman Empire fell to the Ottomans in 1453, or indeed that such changes might have been occurring all along during Byzantium's 1,000-year history. It's only now, in the early 21st century, as we see climate change unfolding before our very terrified eyes, at least my eyes, that archaeologists and historians are challenging with serious evidence the notion that environments have stayed stable over the last 3,000 years. If environments are not stable, if climate has changed, and changed in multiple ways, multiple times over recorded history, that introduces a new variable of potentially enormous explanatory power to our investigation of change in past societies. These societies, let us not forget, were essentially agrarian and crop dependent, that is, extremely weather dependent, until the late 18th century, or later still in most of the world. My comments this afternoon will be both programmatic, talking about what we need to do in the future, and they will offer a few examples that suggest the potential of synthesizing the humanities with science in climate studies. Programmatically, I would like to highlight two questions. What do we need to do, and how do we need to do it? First of all, what do we need to do? We historians have special skills at finding, analyzing, and interpreting the rich but fuzzy, ambiguous, and incomplete written record of human testimony. We need to apply our historical creativity to three great tasks. First, to create a usable critical record of pre-modern climates from written and archaeological evidence. Secondly, to collaborate with climate scientists to correlate the historical, archaeological, and the natural scientific data. Thirdly, to use all the evidence, historical, archaeological, and natural scientific, to discover the patterns of interaction between past climate change and past societies. Our critical creativity as historians must engage in a collaborative venture with and for climate scientists. And we must overcome the manifold challenges of communicating across disciplinary frontiers. Let me share with you the experience of one professor and his student team in creating new geodatabases of climate evidence from Roman and post-Roman historical records. This experience concerns what we put into the critical record and how we use the critical record that we produce. Then I can tell you a little bit about what we've learned recently about climate change under the Roman Empire and in post-Roman times. First, when we produce a critical record of historical evidence about climate, obviously we historians need to respect the canons of our historical discipline concerning rigor of analysis, citation, historical criticism, distinguishing independent from derivative witnesses, liars from truth tellers, accurate from inaccurate dates and descriptions. But we need also to do more. We need to take into account the challenging needs of climate scientists, economists, political scientists, biologists, who will use our critical record. Now, we historians are specialists of human beings and their utterances. That means we are especially adept at making sense out of fuzzy data, at working with the ambiguous nature of human written testimony. If you don't believe me that human written testimony is ambiguous, I ask you if you've ever been part of a misunderstanding arising out of a garden variety email. If so, you'll get an idea of what I mean by the ambiguity of human utterance multiplied by expression in dead languages couched in distant and often quite alien civilizational presuppositions. Reflecting our complex source materials, we historians also tend to formulate our observations in complex, nuanced, and even ambiguous and even fuzzy terms in a way that sometimes drives our natural scientist colleagues crazy. But we must recognize that our best research will be useless to climate scientists unless the phenomena we document are evaluated in a way that lends itself to numerical analysis. That means rigorous classification and numerical values to describe at a minimum the record reliability and the strength and spatial extent of each phenomenon recorded. Here you can see how we quantified in very simple fashion strength, spatial extent, and certainty of climate phenomena recorded in ancient written sources and a few archaeological ones on a 1-to-4 scale in our freely available geodatabase of Roman climate data from written and archaeological sources. Secondly, the historical record cannot and should not stand alone. We must use the historical record in conjunction with the natural scientific proxy data. At that international conference of climate history, I was really kind of stunned to discover that the organizers had invited to this Science of the History of Climate Change international meeting only historians. At least in antiquity and in the Middle Ages, the written and archaeological sources are rich but uneven. Big and unpredictable gaps undercut coverage of most periods, most places, and most phenomena. Arguments from silence, in other words, are useless. We cannot therefore build up and interpret a climate history from the written records alone. To reconstruct ancient climate history, we must also use the full panoply of natural scientific proxy data, hence the need for collaboration. The historical record by itself is too incomplete to allow a full and rigorous understanding of ancient climates. We must integrate our historical record with natural scientific signals of climate deduced from tree rings, from ice cores, glacier movements, and so forth, in order to reconstruct an informed history of climate over time and over space, expanding the detailed knowledge presently available to us beyond 100 years, our present horizon, to 2,000 years or more. That is what our research groups have attempted here at Harvard in recent years. Our first concrete result was a study of the possible effects of volcanic aerosols in early medieval Europe. Of course, we tried to use the scientific data every bit as critically as we use our historical evidence. That in itself imposes its own model of research, which brings me back to collaboration. No climate scientist I know claims to master every type of proxy record. Our colleagues spend their lives understanding the intricacies of usually only one kind of proxy record: ice cores, tree rings, speleothems, glacier movements, etc. If the dendroecologist cannot master the evidence of the ice core specialist, how will we poor historians control all these different, complex forms of evidence? The answer is simple: we cannot. We must therefore seek collaborators who understand the various evidentiary types at the highest level so that we can use the proxy evidence rigorously, especially with respect to the difficult issue of chronology. Much has been written about Bronze Age or Maya collapse, but the dating of the climate proxies and/or societal collapses themselves are often only approximate. And it is sometimes, for me, difficult to be certain that climate change actually preceded the societal collapse which it is supposed to have caused. For the historian, the payoff of such a transdisciplinary approach is important, as I can illustrate with a few examples from our recent projects. The first was led with another historian, a prominent climate scientist, and our own Nick Patterson of SOHP a few years ago. We compared the record of extreme volcanic eruptions somewhere on the globe as recorded in the chemical GISP-2, the Greenland Ice Sheet Project 2, ice core sulfate deposits, which are caused by extreme volcanic events, with extreme winters recorded in Western Eurasian historical sources in the time of Charlemagne's revival of the Roman Empire around 800 AD. Extreme volcanism is known to cause rapid cooling by blocking solar radiation. We were able to correlate the ice core's volcanic eruptions with extreme winters in Europe and Western Asia, mentioned in Latin and Greek records, and for the first time, explain the seemingly random series of famines and catastrophes that befell Europe in these centuries. There were many lessons to be drawn from this first correlation of natural scientific evidence with the written record, particularly for how human systems responded or not to the exogenous and unexpected blows of rapid climate change. It's also important to stress that climate forcing's harsh blows to food production are not regularly distributed over time and perhaps also not over space. History does not deal all players a level playing field, as you can see from this chart. There were no volcanic winters over the long regnal span of Charlemagne from 768 to 814. But a child born in 820 would have experienced 5 such crises in the same span. Charlemagne was more than energetic and smart. He was also very lucky. His sons and grandsons were not so lucky, and the European economy under Charlemagne's successors experienced such a crisis, on average, every 12 years. Add to that civil war and Viking, Arab, and Magyar invasions, and you have a recipe for big trouble, which in fact ensued. For historians, perhaps the single most important methodological conclusion is that we can detect intelligible patterns of cause and effect in what we hitherto viewed as unintelligible or at least as patternless, the occurrence of a climate anomaly with serious economic and human consequences. Furthermore, this graph drives home that even in the early Middle Ages, history is global. Although the specific volcanoes specialists have hypothesized as causing the Greenland deposits have not, for the most part, been chemically verified, there is no doubt that they are legitimate candidates. They erupted as nearby as Iceland and as far away as Japan. The specific human responses that arose in early medieval Europe arose from challenges stemming from a global climate system. The successful integration of scientific and historical evidence in this test case encouraged us to try something on a bigger scale, even if the results would perforce be that much more provisional, pending the availability of new scientific data. This was the second concrete result for our investigations of climate change in antiquity and the Middle Ages. We drew together a kind of dream team of Harvard, national and international experts in climate change and different kinds of scientific proxy evidence to write a white paper describing the current state of our knowledge of climate change under the Roman Empire and post-Roman civilizations. This was, without question, the most difficult article I have ever written, and not simply because it was written with 12 very able but very different specialists on many different continents. It was enormously challenging intellectually to integrate very different kinds of scientific, very different kinds of historical evidence with differing degrees of chronological resolution. But it was well worth the effort because the study identified a number of important questions that need deeper research and more data, and suggested some important hypotheses about the impact of environmental change on key aspects of the Roman economy and ecology. It left no doubt, for instance, that the period of the empire's rise and subjugation of northwestern Europe corresponded to a time of exceptionally favorable and exceptionally stable, I emphasize stable, climate conditions in northwest Europe, a Roman climate optimum. In a sense, warm temperatures and balanced, even rainfall probably encouraged the extension northwards of Mediterranean agrarian organization and crops, for we find in this period that Britain produced wine and boasted a heat-loving beetle as far north as York, things that would recur only twice in the next 2,000 years, during the medieval warm period and again in the closing years of the 20th century. Secondly, as Kyle has intimated, the Roman climate study pointed up a clustering of extreme volcanic events with their potential impact on food production via unusually rigorous winters and dismal summers in periods previously known as times of political, military, and economic unrest in the Roman Empire's northwestern provinces in the 3rd and 5th centuries AD. Now, the historian's creed includes the principle cum hoc is not propter hoc, simultaneity does not prove causality, but of course it is the indispensable sine qua non for investigating potential causes. Thirdly, our team identified, on the basis of unusually dense written records and written records alone, a subtle but apparent shift in the overall productivity of Nile River floods, which fertilized the Roman Empire's breadbasket, occurring around 155 AD. Extremely fertile flood years were percentage-wise more frequent, and very poor years less frequent before 155 compared to after 155. This new observation needs to be tested against new scientific proxy records that must yet be devised, collected, and analyzed. But if it should hold, another element must be added to the extraordinary constellation of favorable conditions that prevailed during the Roman Empire's rise and to the enormous challenges that befell the empire during the near-fatal series of crises that began with the Antonine Plague in 165, about which Kyle and Johannes have already spoken. Less food from the Egyptian breadbasket was available for the capitals and armies after 155. Could this have weakened the population before the arrival of the Antonine Plague? So these are aspects of the two greatest crises in Roman history where scientific evidence beckons historians and archaeologists to dig more deeply in order to introduce solid data where before there was little more than supposition. This study marks only the beginning. Much careful research will be needed before we can conclude that climate events contributed to the empire's rise and then to its disarray, and to evaluate how much and in which way, to explore, for instance, the interplay of climate and the health crises that hit the Roman Empire in the 2nd, in the 3rd, and in the 6th centuries. But I rejoice that our study has already begun to trigger new climate work. Geologists in Israel are analyzing a new old lake cores to see if it's possible to dispel some of the ambiguities that emerged from our study using their evidence. And a whole new international working group has just been formed at Princeton University to take up the challenge issued by SOHP's study to improve and critique our general picture with integrated regional studies of climate change over the last 2,000 years. In Princeton's case, they're going to study climate across all of Asia Minor, Anatolia. Nor is it only antiquity and the Middle Ages whose history is gained from integrating scientific and historical evidence. The crises that racked the Ottoman Empire in the late 16th and 17th centuries have gained powerful and unexpected illumination from their analysis in the light of the onset of a new phase in the Little Ice Age. And now that approach has been extended on a vast geographic, if not chronological scale, for Geoffrey Parker's massive new monograph argues that the 17th century witnessed wars and general catastrophe that assumed global dimensions from Britain to China, and that climate change was a driving factor in these crises that shook states and societies around the world from 1618 to 1688. So there is an indubitable payoff for historians and archaeologists to begin to discover and integrate powerful new evidence from their studies of the human past. But historians also have an important, unexpectedly important role to play in the scientific reconstruction of past climates. Scientific history is truly a two-way street. Our written evidence, it turns out, is the best critical control for the accuracy of the mechanisms climate scientists deduce from comparing modern instrumental readings and modern scientific proxies. These modern scientific analyses rely on comparing proxy signals with truly rigorous instrumental records across the globe that only go back very often, in most cases, in fact, 3 or 4 decades, 100 years, 200 years at best. Some have even challenged creating pre-modern climate proxies for modern instrumental evidence as fundamentally flawed because the human impact on the environment since the Industrial Revolution may have been so deep and so fundamentally changed the climate system as to invalidate the retrospective pre-modern application of proxy climate mechanisms deduced from 20th century data. The capacity of medieval written records to test the deductions of climate scientists from natural proxies show that this challenge is false. A couple of years ago, historical records confirmed the dendroecological reconstruction of April, May, June precipitation of northeastern France, northeastern and southeastern Germany for every spring from 250 BC to 2000 AD, based on 7,000 series of tree rings. I asked the dendroecologists when they were completing this study for all the extreme droughts and rainfalls from the later Middle Ages, expecting that the written record would be strong enough then and there to test whether in the same places where the trees were growing, eyewitnesses actually observed what the dendroecologists claimed the trees were telling them was happening with precipitation. The dendroecologists identified 32 extreme precipitation years from 1013 AD to 1504. For them, I was able to identify 88 eyewitness accounts composed in the areas where the trees were growing. For 30 of those 32 years, at least, one medieval eyewitness reported the same precipitation extreme as the scientists deduced from the tree rings, offering completely independent historical confirmation of the accuracy of the dendro reconstruction of spring precipitation. A wonderful case of Ed Wilson's consilience. Now, one of our talented undergraduates, who's present here, has taken this analysis to the next level, exploring the relations between the scientific precipitation reconstruction and one wonderfully rich medieval document, the diary of a 15th century Frenchman, as you can see this afternoon in Lila Hoffer's fine poster. Clearly, we can use our historical records to test, calibrate, and reinforce scientific methods. So where do we go from here? For our research group, two important projects beckon. Francis Ludlow, also present here, is one of SOHP's first postdocs, made possible by Dan Schragg's Harvard Center for the Environment. You can discuss with Francis his fascinating poster on medieval Irish chronicles, tree rings, climate, and social history. Now, Francis and I are organizing a study by another all-star cast of historians and climate scientists that will investigate jointly the historical and natural scientific evidence for 5 major climate crises we've identified between AD 536 and the 1420s, adding this time, we hope, to the European evidence, new material from China and Japan, as well as the latest scientific records. By focusing on 5 events in great depth, we hope both to arrive at a more precise understanding of these instances of climate change and their human impact, including the possible climate background for the outbreak of Great Plague pandemics, and to clarify the respective strengths and weaknesses of the historical, archaeological, and scientific records, and also to define more precisely marker events for a new and daring enterprise. All of these consilient studies so far have compared and integrated historical materials with scientific data that has already been collected and analyzed before we turn to it. I would argue to this gathering that the collaboration of scientists and historians must go further than comparing materials already gathered. As we work together, our collaboration is leading inexorably to new questions that neither humanists nor scientists have thought of by themselves. This kind of fruitful collaboration leads inevitably to the discovery of new problems and daring new research questions and even strategies. And that intellectual stimulus ultimately invites joint historical and scientific investigations aimed at producing new evidence from new scientific sources. This is not just theory. As Bud Balin knows, I'm not very good at theory. In August, with the generous support of the Arcadia Fund of London, headed by 2 generous Harvard alumni, Harvard University's joint expedition with our colleagues, Professor Paul Majewski of the Maine Climate Change Institute and Dietmar Wagenbach of the Heidelberg Institute für Umweltphysik, successfully recovered an ice core from a glacier on the Swiss-Italian border. Professor Majewski's lab has developed an advanced new laser apparatus, which for the first time allows ultra-high resolution analysis of glaciochemical signals at annual or perhaps even subannual resolution from the low accumulation ice of a Swiss glacier. We expect to recover a strong climate and environmental record back to the year 1000, and indeed, we hope even to reach deep into the first millennium of our era, or perhaps even further, to produce a chemical record of temperature, of precipitation, of storminess, of metallurgical pollution, to be able to map year by year the metal production of the Roman Empire, and much else from the heart of Europe. We will compare that glacial chemical record with the other proxy evidence in which Europe is so extraordinarily rich, as well as with the historical record of climate data now being assembled into a comprehensive geodatabase by our students present in this room. We expect that the new ice core will create a big new set of highly resolved, hopefully annual, proxy data for historians and scientists of Europe's environment. We also hope it will deepen our understanding of the great cores drilled and analyzed elsewhere in the Northern Hemisphere, the great cores that are the foundation of our understanding of the evolution of the climate over the last many thousands of years, the cores drilled notably in Greenland, and the somewhat controverted testimony they offer on the climate of Europe. At the poster session, you can meet our team member who is leading the new LA ICP analysis in Maine, Dr. Nikki Spalding, who took part in the dangerous and successful drilling expedition led 2 months ago by the intrepid Dr. Pascal Beauleber. Their poster offers the very first report from the new project. So there you have it for now. By synthesizing the results of science and history, we all stand to gain. Historians, economists, political scientists will have a powerful new set of variables to explore when trying to understand change and the performance of past and present societies and economies. While climate scientists will have gained 2 critical new data sets, the most powerful of all proxy records of past climates in the form of human witnesses who were present and tell us whether the mechanisms that science has deduced in fact operated when, where, and as predicted. And last, but by no means least, the possibility of comparing present and past extreme climate events, rare by their very nature, through an integrated, deep historical and scientific proxy record of climate events and human responses over the last 2,000 years. And in this, perhaps, it is indeed true to say that the collaboration of historians and scientists working on ancient and medieval climate change can somehow contribute to the future of humanity. Thank you.
Thank you so much, Mike, for a fantastically inspiring and exciting case study of the benefits of collaboration, of translation from one discipline to another, which has multiple benefits for all of us, which I think Mike has so eloquently shown. I'm sure Mike would be happy to answer questions, and I'm sure there'll be many from the audience. So I think I will hand over to you. Any questions?
Erwin Shapiro. Here comes the microphone.
Okay.
Thank you for a fascinating talk. It was really great. I was wondering if there's any interest in such looking at proxies like ice cores for climate to extend this globally so we have a feeling for what the whole Earth was like climate-wise in these earlier times. So that
That's a great question, Erwin. And in fact, it has been done. There's a number of very important ice core projects, including some led by Paul Majewski going on in Antarctica. The biggest challenge has been to get to mid-latitude ice cores, whether in Latin America or in Africa. Kilimanjaro is a famous case. And Lonnie Thompson is a great ice core specialist at the Ohio State, I think, who led the work on Kilimanjaro. And there the ice is melting very, very rapidly. This is also true in the Swiss Alps, and we felt that it was very important for us to gather this particular core because we're not sure how much longer that glacier is going to be there. Glaciers melt from the bottom as well as from the top up. So they're in a very precarious state. This is going on everywhere. What has not been done before is something like this in the heart of Europe, the reason being for and Nikki Spalding can explain this much better than I can, but the technical conditions of the accumulation of the ice in the Alps. That we're looking at about 7,200 meters depth. and whereas in Greenland you have thousands and thousands, tens of thousands of meters, thousands of meters at least going down. So it's a very difficult thing to analyze, and up until the development of this new apparatus in our friend Paul Majewski's laboratory, it's been impossible to analyze. The analysis was based on centimeter segments, and when we get down to the bottom of this one, we don't know how many decades may be in a single centimeter. But with the new method, what is it, Nikki? The LAICP will do 250,000 measurements in a meter, is that right? Okay, 510? 501 centimeter. Okay, 501 centimeter, there you go. So it's a whole new ball game. So that's why we're trying this, and combined with the fact that it's right on the border of Italy. I mean, we picked up a fly, should have put the slide in. Nikki saw a fly from the 16th, 15th, 16th century that must have blown up from Milan there. There's incredible stuff there. We don't know what's to be found. Johannes and I have been talking about doing some experiments just to see what's up on the ice in forms of microbe going back. So it's been done. People are well advanced in this around the world. The problem is also in the Himalayas, but the ice is disappearing in many of these places.
Hi, I'm Naomi from the University of Reading.
Naomi Ritterford, thank you.
Naomi Ritterford. It was a fascinating talk, and I think that what you're trying to do is really incredibly helpful. My experience of looking at records that are environmental records that go back thousands of years is the difficulty of being able to disentangle whether it's a climatic influence on environmental change or a human influence, causing environmental change. And I think that what you're doing here could potentially help to shed some light on that. I was just wondering if it's possible within the historical records to disentangle, if you like, that human versus climate effect on the environment. If it would be possible to look in the documents to see if there's any comment not just on climate change, but possibly environmental change that could be directly linked to that climate change.
That's an interesting question, a very challenging one, Naomi, thank you. There have been efforts by climate scientists rather than by historians to explain things like the medieval warm period from the fall of the Roman Empire and the contraction of plowed fields, and therefore the expansion of forest cover, which you know from your own paleobotanical work is well documented in the immediate post-Roman period. So you have many more trees, and therefore they're dark, and therefore they absorb more heat, and therefore the globe heats up. But so far that has not proven convincing to many of our colleagues. The evidence is more likely to come, I think, aside from the question of erosion, where archaeology and history have an important role to play. I think the evidence for a potential human impact on climate is more likely to come from the archaeological and the natural scientific record than from the historical. But it's a great question, and we have to keep our eyes open for it. Thank you.
Oh, hi, I'm Anne McGrath. You probably tell from my accent, I'm from Australia. And I was noting that you were talking about written records left in the ancient past. I was just wondering whether we can extend this at all to art, and thinking of the rich visual record we have of animals and plants and so on that are often depicted on rock walls. And this is something that I've noticed, that archaeologists study rock art, and dating experts and geological material science experts, but I'm always rather concerned that historians don't seem to be part of that game.
Yeah, I think that's a good point. There is certainly iconographic evidence that is extremely valuable. The case study that I happen to know best is that by Wilhelmina, my old late friend, good friend, I don't know if she's still late, Wilhelmina Yashemski's great study of Pompeii, the natural history of Pompeii. And one sees right away there some of the difficulties. The painting in Pompeii is very naturalistic, very realistic, but there's great debate about whether what she has identified as a lemon is indeed a lemon or not. And this is very important because the introduction of citrus beyond the citron into the Mediterranean, into Western Europe, is a very, very important element in the general health history and kind of the biotic history, the biological history. And I'm afraid the iconographic evidence is simply not satisfactory on that particular score. There will be other cases where it will be most helpful. along with archaeological evidence, paleobotanical, archaeozoological. I mentioned the nettle bug that was identified in York. So I think that certainly iconography has something to bring to this. We'll leave it to other specialists to do that, though. I'm already spread pretty thin. Thank you.
Alan Cooper, Colgate University. Mike, will you take a deliberately silly question? Do you as a historian...
I always take silly questions, but the answer will be just as silly. You know that, Alan.
Do you as a historian find it depressing that Charlemagne's genius turns out to be attributable entirely to volcanic luck?
Actually, I find it rather refreshing. Good question. It's not silly at all, as you intimate. Of course, Charlemagne's success was surely not due exclusively to the absence of volcanic eruptions. He had other crises that he had to face. And he was an extreme, I mean, as you well know, Alan, I've spent a lot of time thinking about Charlemagne and reading the documents written in his presence, often we suspect with his sometimes cutting commentary on the events that were going on around him. He was, without question, an exceptional individual who happened to be in existence at an exceptional time. And he made exceptional use of the circumstances that surrounded him. How would he have fared if he had been born in his son's time and had to deal with those crises? Hard to say, hard to say. But I think that any historical development, such as we're discussing here, is the result of an extraordinary conspiracy between the givens of the environment, the capacities of the individual, and random events. We tend in history to want to explain everything and to see these very carefully. We construe wonderfully complex chains of causality, but we must not lose sight of the fact that stochastic events, random events, the timing events, the convergence of two otherwise innocuous events in the same time in the same place can have nonlinear consequences. That causality in history is nonlinear. It reflects, it doesn't, a small cause can have a big effect, and particularly when you have these complex feedback mechanisms whirring back and forth. So I think Charlemagne was lucky, but he was more than lucky. Yeah, good. Thank you very much.
Yeah, I think looking at the time, I have to thank Professor McCormick so much. I was just, the last bit of the discussion was making me think. I was wanting to ask Mike about, given all the success in translating historians' fuzz into numbers, I was just thinking about what the role for the historical fuzz was, and I wonder if it is in trying to reconstruct experience of climate change through both documentary and archaeological evidence. But that's just a pass, and bioarchaeological evidence. Yeah, and that I know you've done work on.
Yeah, I think it's fantastic. Yeah. Exciting. The future is exciting. Thank you.
Thank you so much, Mike. Thank you.